Hello and welcome to Repairs with Ron. Hope you're doing well today. Today we're going to be talking about the thermostat and an ECO on a Dometic water heater. As you can see here, they're very similar looking, but there are some differences in between them, so we're going to discuss what those are. We're also going to do a small demonstration on how they function and how to diagnose them. Alright, let's start off with the differences. On the right is going to be our thermostat, and on the left is going to be our ECO. If you're not sure what the difference between the thermostat and the ECO are, the thermostat is designed for normal operations, which turns on and off the water heater as it reaches the designated temperature that it's supposed to heat to. The ECO is designed to protect the water heater from overheating, in essence. If this thermostat fails in the closed position and will not shut the water heater off at normal temperature that it reaches, this will take over and make sure that it doesn't overheat to the point where water may boil in the water heater. We're going to talk about some of the physical appearances first, difference-wise, and then move on to the actual back of them, which you can't see while they're installed, but since I have these out of a water heater, you can take a look at them. We'll start with the front of these. If you take a look at the spades are actually different sizes. The one with the smaller spades is going to be your thermostat, so you can just visually see that. But the other thing is going to be on the back of them, and you do need to remove it. If you take a look here, there's some writing on the back, and you'll see here that they're going to be at a different rating temperature-wise, and the rating is in Celsius. So if you take a look at the thermostat, you can see that's a 60 degrees Celsius rating. So what happens is this is a closed component until it reaches 60 degrees, then it opens and shuts off the operation. If the thermostat fails, though, the ECO is supposed to take over, and if it overheats past that 60 degrees Celsius and ends up going to 82 degrees Celsius, this will pop, cutting off the operation again. So there's kind of a backup. That's what the ECO is designed for. So for reference, that thermostat is going to be rated at 60 degrees Celsius, and the ECO is going to be rated for 82 degrees Celsius. For Fahrenheit purposes, 60 degrees Celsius is going to be 140 degrees Fahrenheit, and 82 is going to be 179.6 degrees Fahrenheit. Now, to diagnose these components is very simple. All you need is a standard meter to do this with the option for continuity. So go ahead and we can flip the meter on here. Once the meter's on, we just want to check to make sure that our leads are in good condition. So we'll slide this up here. All right, and we'll just do a quick test. It should beep on you. And then all you do, again, these are supposed to be closed circuits. So you will go to one post with one lead and the other post with the other lead, and you should have continuity. If you have no continuity there, that's going to indicate that that circuit is open and it's possible that it's bad. Now, does that always mean it's bad? No, it depends on the temperature of the water inside the water heater. If the water is at 140 degrees Fahrenheit, this would be an open circuit. As long as it's under that and it's not operating, that would be under 140 degrees, this should be a closed circuit. And then the same here, this one just that 179.6 degrees Fahrenheit, as long as it was under that, this should be a closed component, unless it was the temperature was over that, where it should become open. And the last thing we're going to do today is just a quick little test to show you how this functions. We're going to heat this up manually, and hopefully you can hear kind of the little pop that the thermostat makes when it has reached temperature inside the water heater. And then we'll do a continuity test so you can see that it's an open circuit. And then it should reset, and we should be able to retest it again. It should be a closed circuit again. So what I'm going to do here, just to protect my fingers, I'm going to grab this with a pair of pliers. Okay. And if you're quiet, again, you should be able to hear this, but we'll try. So there's just a small little click there, and that's going to indicate to me that this component has popped. And if we're very quick about it, we should be able to get there, and there's no continuity between it. But as it resets here, as it cools down, we should be able to hear it possibly click and reset. And there it goes. So that is going to be how those components work, and a little demonstration on how they work. I appreciate you joining me here at Repairs with Ron, and take a look at some of our other videos, and have a fantastic day. Bye, everybody.